So hello guys. So in this video we'll talk about what Anagram is, and I'm going to talk about how we can solve problems like Anagram problems using Python. And there are lots of ways. Let me talk about what Anagram really is. So as you can see over here, Anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. Okay, so you know so let's take this apple word, and what do you think? Anagram is like, I'll come there, but I just want to test you whether you can explain what anagram is. Okay, just a little second. Okay, just okay. So back to the video. Okay, so anagram is a word, and it's like, it's related to word, and it's like, let me give you one example. So this is one of the word that is called apple. As you can see, this is an apple. Let's call it as s1. Okay, let's call this apple as s1. And what do you think? So if I need to compare this with this, do you think banana is an anagram of apple? What do you think? Do you think that this banana is anagram of apple? What do you think? Is this? No, it's not. Why it's not? What can be the reason why you think like banana is not an anagram of apple? What can be the reasons? Okay. So the let me tell you the very first reason. Okay, explain you the very first reason. Then. So the very first reason behind this is, first thing you need to notice, the rule, a kind of like rule that makes a word anagram. The first rule is, you know, let's consider that. Let's say we have two words. Okay, the first rule is like, let's say that we have two words. Okay, let it be apple and banana. Okay, the first thing is length should be equal. Okay, do you think the length of banana and apple is equal? Definitely not. As you can see, the length of banana is different and apple is different. Okay, so this is the first rule. The first rule is the length should be equal. The second rule is, second is uh, second thing is, each of the letter in both of the word should be similar. Okay, so as you can see that, do you think like the words each letter in apple is similar to banana? What do you think? It is or it's not? It is definitely not. They both are different. And when you compare with this, with apple, as you can see that the length of this word and the length of this word is equal. And the second thing is, whatever letters we have in this string, we have in this what do you call word too. Okay, so as you can see that ELPPA is anagram of apple. The reason behind this is length is equal, and the second thing is each letter of both the words are similar. So this is the reason why ELPPA is anagram of apple and why banana is not anagram of apple. Okay, so that's it. So let's come down below. So uh, there are lots of ways from like there are lots of ways that we can use to solve anagram problems using Python. Like we can clarify whether a given word is anagram or not. And there are basically three ways on how you can solve anagram problem using Python. The first way that we're gonna use is checking off, and I'm going to explain what checking off really is. The second way is counting and compare. Count and compare. The word is something else, and you know the thing is actually something else. And the third one is sort and compare. So these are three ways on a like that we will be using to solve anagram problem using Python. Okay, so let's go on with the first way. As you can see, the first way is checking using solving using checking off, solving anagram problem using checking off. And there are some steps that we need to follow while using this way, solving anagram problem using this way. Okay, so the first step is check the length of both string. First thing that you need to know, this is the first thing that you need to you know uh, think about. Okay, the first thing is you should be checking the length of both string. This is the first step. Second step is check. This is second step that you need to follow. And the time complexity for this is n square, as you can see, because we have two iteration in this program. We will be using two loops. That's the reason the time complexity over here is n square. Okay, now we'll jump back to the coding section. Let's jump back to the coding section, and let's open your VS Code. So this is my VS Code, and right now we are using checking off weights to solve anagram problems in Python. Okay, and as you can see, this is the step that we will be using. So let's begin. This is basically not my code, but I know the logic behind this. So the first thing is we're taking a variable that is still okay. What this is going to do is this is going to check it's going to uh, check whether the two of the length is equal or not. So let me write some more code and then you'll understand what it really means. Okay, damn, what the heck I'm typing. So the first thing is here what it's going to do is what it is doing is check that both string is equal in length or not. So this is what it's doing. Okay, checking if both the string is you know equal or not. Both the string are equal or not. It's first checking that. If it's not equal, it's going to state this still okay value as false. Okay. The second step that you're going to do is you're going to convert the string to second string into a list, and this is going to be index of string 1. Okay, we'll say like s1, and we're gonna say like what we're gonna do is we're gonna go to each of the, what do you call it, s1 later. Okay, what do you want? We want to go in each of this layer. We want to check each of the layer. That's the reason why we're using while pos position 1 less than the length of the s1. Okay, that is what would be the length. What is the length? We'll determine after, like, for example, what is the length of pen? So if I'm using s1 as pen, the length would be 3. Okay, that's it. That's what I'm talking about. Still okay. Then it's going to be this. And what I'm doing this over here is this is the index for s2. Okay, let me tell something again. Index of s1. This is it. Found equals false, and while position second. So he from in this section, what we have done is we are iterating the s1 word, you know, position. Okay, we what we're doing is we're validating like whether it's true or not, whether these things are true or not, whether we have checked each and every, letter of this s1 word or not, and whether, it's still okay, is true or false. Okay, that's what we're checking it at first. Now what we're gonna do is we're gonna check the, we will set something like the kind of like restriction, like whether our loop will go till the second string or not. We want every single string to get looped. We want every single string to be checked. That's the reason why we're using this iteration. Okay, and we have something like not found. Now what I'm gonna do is if s1 position 1 equal to, what we're doing over here, we're checking the first letter of string, first letter of s1, and we're checking first letter of s2, which is called a list, as we have already changed this into list at first over here, as you can see. So due to that, we don't have to change, we don't need to change it into a string, or like we don't need to write something like s2 over here, as we've already changed in the supplemental list. So we will say found equals true. So if this two letter, if the letter over here and the letter over here, if the letter, first letter of s1 will be equal to each and every, each and every, maybe like each, like one of the letter of s2, then it's going to be like found is going to be true. That's what is what we, our logic is. Okay, and if it's not okay, let's say like, it's going to the first iteration. The first iteration of s2 is like, let me explain something like, let's say as I have something like s1 to be as apple. I need to use something else. Let me use something else again. So let's consider that I have a string that is called s1 to be as apple. Let's say I have a string s2 that is called LEPPA, and what I need to do is I need to check this a. I need to find like whether a is available in s2 or not. I need to check that. And for that reason, what I have done is I'm checking each in each of the letter, like each of the letter of a list. That's what I'm doing over here, as you can see, and that's it. So found if we found that list, if we found that, as you can see that I'm gonna iterate this A. I'm gonna check this A is available in this part or not, in each of this, this part or not. If it is available, what I'm going to do? What I'm going to do is I'm gonna set that position as long. So as you can see that if I took Apple as S1 and LEPPA as S2, then in the first iteration of S2, in the first iteration of S2, you know, the A list will look like, A list would look like something like uh, L E P P and something like, I think it's not over here. Okay, then it would look something like this. Okay, so what's happening is it's setting, as we know that it found A. So that's the reason why I have what I've said over here. In place of A, I have said none. So that's what it is doing. Okay, in the first iteration. Else, it's going to be false. So local is going to be false if it couldn't find A in if we don't find A in S2, then what's going to happen is this whole program is going to get stopped, and still OK will be false. Still OK will be false, and when it again iterates, what happens? Let me explain. Let me tell you what happens. Okay, it's going outside. So what happens is Ishiloki will get false, and when it again iterates, it's going to check whether Ishiloki is true or false. And as we know that it's already false, it will return whatever value this Ishiloki have, and it's going to return false. And that's what the value we're going to get. That's the value we're going to get. Okay, that's it. Let's see the output for Apple, and let's see the and LPPA. Okay, let's say I think it's damn. LEAPPLE. Why it's getting false? Damn, why it's getting false? Let's take something else. Okay, let's take example. I don't know why it's getting false right now. False. There must be some kind of like supervision, like whether it's why it's getting false. Should be one over here. It's false. Still false. Still false. Still false. I'm gonna find this. I'm gonna find why it's false. So what we did was we took a variable that equals to, okay, that's true at first. We checked whether s1 is equal to s2 or not. We checked s1 and s2, and we know that it's true. It's equal. S1 is equal to s2, and what we get? We get nothing. It didn't program didn't go into this block, and we went further. We converted s2 into a list, stored into a list, and what we did is we set the position 1 at 0, which and now we started iterating the S1. We iterated for the first time. We iterated for the first time, and we're gonna get something like found equals false again. We set the value of found as false, and then we start again and then position to like one if found none, and if found none else it's false. No, why is it's giving us false value? No region. Damn. What we're gonna do is we're gonna use ChatGPT now, as we don't have, I just don't see any option. It was working fine. Oh, it was working fine. This way, the way I'm solving this problem is was working fine before earlier, and now it's not working. Let's do this thing again. 'Cause I don't want any kind of thing like to happen. Let's solve this problem again and let's find where the error was. It's going to be true if length s1 be not equal to length s2. We're gonna set still okay as false. And the next thing is we're gonna convert this as 2 into a list, and that's what we can see. Took the first indexing whatever value as port 1, and it should okay. Position 2 be 0 if found equals false, and while position be less than a list and not found, then what we're going to do is if s1 position 1 will equal a list, it's going to be position 2, it's going to be found equals as it's already found, it's going to be true, and else what we're going to do is we're going to add this string, I mean the index. We're going to increase the index of s2, and we're going to do what we're going to do is if we found in the all the index of s2, then what I'm going to do is I'm going to state that index as none, and else what I'm going to do is still okay be false, and position 1 will be equal to position 1 plus 1, and what I'm going to do is I'm going to return the still okay. That's what I'm going to do. Again solution and I'm gonna use F4. I'm gonna like, no. Let's check it again. Now it's working fine. Okay, so there was some error with okay. Okay, so now it's working fine. As you can see, this is the first way of how you can solve your problem using checking of your way. Second way is we're gonna use something called count and compare. So the count and compare is like, first we're gonna use create two list. First step is going to be like we're gonna create two list, and the two list will be filled with zero value. As you can see, the T2 list will be filled with zero value. So whenever we get index that matches with that particular index, and it's going to fill that particular index value as plus one. It's going to increment that index value. So that's what it will do. And the second step is going to be we can iterate the both uh, you know list both list, and we're gonna check whether or not uh, let me think whether or not let me think. Okay, whether or not the both lists are equal or not. If it's not equal, okay, so if it's not equal, it's going to set the value as still okay as false, and it's going to return false, and that will be the answer for this program. Okay, so let's begin this program, and I'm going to show you how it works. The first, as I told you, what we're going to do, we're going to create two list. We're going to create two list. Okay. So what I'm going to do is I'm going to fill that value with plus one. I'm going to iterate each of the value. I'm going to fill the value with plus one, and I'm going to compare each of the list. And if I found the list, if I found the list, I'm going to increment the j, mean second index. If I didn't found in the value, what I'm going to do is I'm going to uh, I'm gonna set the value of still okay as false and return that value. That's what I'm gonna do. And time complexity 0 n when n, let's say n, as n is linear time complexity, means that there will be just one iteration. Okay, there will be only one iteration. That's what I've understood. S1 I've taken S2, and this is C1. I'm gonna create two, you know I'm gonna create two lists, and that list will be filled with zero, as you can see. What I'm going to do is I'm going to fill the value now. I'm going to fill the value with zero, and for that I'm going to use something called ORD. What is ORD going to do? It's going to give me the Unicode value. It's going to give me the Unicode value of each of the letter. Unicode value of each of the letter, which is plus one. I'm gonna take second list. I'm gonna check S2, going to be ORD. S1 I minus ORD will be A. I'm gonna use something called post equals C2, post plus 1. I'm gonna use something called J equals 0. Still okay. It's going to be true, and while J less than 26, and it's also still okay. What I'm going to do is C1 of J is equal to C2 of J. Then it's going to be C equals J plus 1. else still okay, it's going to be false. And what I'm going to do is return still okay. Let's check it if it's working or not. Anagram solution. Okay, so it's working. Let's check another value. Damn, what the fuck? Okay. It is still giving me some kind of error. And the reason behind this is, so what can be the reason? What can be the reason? The reason behind this is we haven't checked something. You know what is that? That is the length of C1 and I mean S1 and S2. We need to first check the length. Okay. So we're gonna first check the length. Okay, so that if length of S1 is not equal to length of S2, then what I'm gonna do is I'm gonna set the value of string 3 as false. Okay, and it was never true. Definitely, it is true at first. Still not true was. Now it will be easier for us to do. And it's just not working. It's still not working because the reason behind this is string index out of range. It was working at first, isn't it? Now why it's not working? Ah, should work. Apple. This will also work. But if I set as, it's not going to work. What is the vision? It's checking S1 and it's checking S2. Why it's not working? Why it's not working? Oh yay! Now it will work. Now it's gonna work. So this is the whole solution. So this is the second solution that we have discussed that is related to solving using count and compare. This was the second solution. The third way is sort and compare. So in the sort and compare, what are we gonna do is we're gonna sort the two list and we're gonna compare the two lists. Simple. It's too simple. This is one of the simplest, way to compare the anagram, and this is the simplest method technique that we're gonna use to, solve anagram, check anagram. So now we're gonna use it. Let's use it. That's one. Let's do. Let's convert the stream into a list. Have you already compared or converted? The first thing we're going to do is we're going to sort this thing, sort the list one. Second thing that I'm going to do is sort the list two, and what I'm going to do is I'm going to get the position, that is position one. Position. I'm just going to use one of the, only one index, okay, for the both of these, list. So while position less than first string length, if list one position be equal list two position, then it will go further to check the next list, I mean index value, index, let's say layer. If it's not, it's gonna change this matches as false, and the program will conclude, stop. Okay, that's what is going to happen. Let's see. Anagram solution. So, PLEAP. Let's see. PLEAP. P. Let's see. True. Let's take some other value. Value. So it is working successfully. So the first thing that we have done is we have first converted this string into a list, as you can see, and then we have sorted this both of the list. We've got the position of, like, we what it is, we set a position at 0. We declare matches as true. For the first time, match is going to be true, and what we're doing is we are iterating with each of these, index values of list 1 and list 2. We checked list 1 and list 2, index. If it's okay, we're gonna go to the next index, and we're gonna check the next letter. If it's not equal, then the match is gonna be false, and we're gonna just return the match's value that is false. And that's what we did, and that's the last way of, this is the third way. This is not the last way. There are lots of other ways that you can use to solve this problem, and this way is called sort and compare way, that we sort and we compare. So this is the final way of how you can solve this anagram. I'm gonna like explain more topics. Okay, if you feel like I'm not good in speaking English, then I'm good. But basically, I haven't prepared the lecture. I mean, topics that should be that can be the reason like why I'm not able to deliver whatever the right thing. Okay, so